There we go. Well, welcome everyone to the winners panel discussion for the WiDS Datathon University Challenge. I'll say that this was the first year that we have expanded the Datathon program into universities, and this year we've worked with over 70 universities across different countries on this challenge. And so we're interested in hearing to see how it went from those some of you instructors who are here on the call and have supported your students through the Advanced University Challenge. And we'll also be gathering to hear from the winners. And so the main goal of today is to hear how the different winners worked on the challenge, and we'll have a chance to ask questions and invite everyone to participate. And so I'm Valerie, I'm the WiDS Datathon Program Director. And Sharda, do you want to also introduce yourself?
Yes, good morning. I'm Sharda Kadanidhi. I'm Technical Director of the WiDS Datathon. I've had the privilege of being involved with the Datathon, particularly the Datathon the dataset preparation piece. So I'm always super excited to meet the winners and the instructors and hear the solutions. Just keep this sort of open and free form, and just a general discussion about how you approach the problem, and also different. I'm interested in hearing about your different research approaches, perhaps research questions that you might be interested in. So I'm really excited to meet you and hear your solutions.
Wonderful. So what we'll do for today's call is we'll be together for a full hour, and we'll hear from each of the three top teams. And so I'll invite each team to present their slide deck presentation for about 10 minutes or so. And then we'll do 10 minutes of dialogue to ask some questions and do some Q&A and conversation, and then we'll move to the next team. All right. And for those of you presenting, if you feel comfortable turning on your videos, we invite you to, but I'll let you decide what you're most comfortable with. So let's kick it off with the first team. And so first up, we'll hear from the first place team from the Technical University of Cluj-Napoca in Romania. And Andrea Maria Onach will present on behalf of her and her teammate. And so, Andrea, if you want to go ahead and get started whenever you're ready and share with us the solution that you and your teammate worked on.
Hello, everybody. My name is Andrea Maria Onach. I'm from the Technical University of Cluj-Napoca, and I work with my teammate, Petruț Betuel Paul. We are both students at the Technical University of Cluj-Napoca in the third year of study, and we decided to enter in this competition because we started studying this subject this year, and we found it very interesting. We were informed about this competition, and we entered in this competition with the thought that why not?
Mm-hmm.
Okay, let's talk about a little bit about our approach. Our model predicts the time between the first diagnosis and the first treatment for woman diagnosis with metastatic triple negative breast cancer, as the task was being told to us. We used very different features, but the most successful one was grid search for searching and XGBoost for the classifying part. The training model took about approximately 2 minutes and provided very competitive accuracy. Also, we tried using light GBM, decision trees, random forests, and as an ensemble, we used the voting regressors. We also started training some neural networks, but the results weren't quite approximately what we expected. But we started combining classifiers and small pre-trained neural networks, and the results were competitive and quite challenging, but not the same, and were not better than what we already have. Okay, the key features included our outlining the removing of extreme treatment periods, scaling the remaining data, and filling missing values with medians for numerical columns and non-value for categorical columns, fine-tuning with depth levels of 3 and 4, learning rates as presenting in the slide, were our best results. Let's move on to the feature selection and engineering. The most important features were the breast cancer diagnosis code, breast cancer diagnosis description, and metastatic first treatment generic drug name or of the first treatment. This is the plot which weighted the inputs of the best features, top 10 feature importance. As we can see, the best one was the breast cancer diagnosis code, the breast cancer diagnosis description on the second place, and on the third place was metastatic first treatment. Okay. Moving on to the training methods, we use different training methods to see their potential in our problem. We did the geometric average of some of the best results of the same model with small differences in the hyperparameters. Important things and interesting findings. Let's talk a little bit about our best ideas, let's say it like that. What distinguished us from the others was our persistent effort to explore new approaches. We were not afraid to try new things, to explore new ideas, and our commitment to frequent updates. Additionally, we are fortunate to have excellent teachers who provided invaluable assistance whenever we needed support. And our teacher gave us a lot of ideas and a lot of new things that we could try on. And it was very helpful. Okay, the simple model. We excluded the least significant features if we would make a simplified version, such as patient gender, education level, meaning that we focus on the people with only the bachelor's degree. No, and not only. That was okay. Let's move on to the less than 10 feature importances. As we saw before, now we have the patient race, which was less important, the metastatic first novel treatment, the income household 15 to 20, race Black, and population. And also we have the zero ones, like income household 35 to 50, patient gender, metastatic first novel treatment type, education bachelor's. And if you have questions.
For sure. Yeah. Thank you very much for that presentation. It's very interesting, the work that you've done. I'm curious. So you explored a lot of different models, and I'm interested. I'd like to know, do you have sort of a comparative performance of each of the different models, and which one actually sort of performed better? I realize you combined some models, right? So do you have something sort of a comparative performance? And secondly, I'm interested in knowing, did any research questions emanate from your work as you worked very, very closely with your instructors? Are there research directions that you think you could go with? Are there unanswered questions? Do you feel like if you had more time, you could explore some unanswered questions. So is that something you can talk about? That would be really interesting to hear. If you had the winning model, but was there more that you could have done? Is there things that you can sort of go in a more research direction?
As I already told you, we tried to combine some classifiers, but it wasn't quite the best idea. I mean, the results were comparable to what we already have, but was not better. I mean, using the XGB boost was the best. I mean, it provides us accuracy. We needed accuracy. We needed also a good time in running as the running time. And yes, we tried to combine a lot of classifiers, but the results were not better than what we already have. I don't think we have had another idea. I think we did our best.
Yeah, for sure. Definitely you did your best. I'm just curious, were there any research questions that you were interested in?
I don't think so.
Okay. All right. Well, thank you very much. This is
Thank
very
you.
interesting and great presentation. Thank you for participating in all your hard work. And we look forward to seeing you again in future competitions.
Thank you.
Thank you.
Thank you, Andrea, and your team for participating in the University Challenge. Wonderful. All right. So next we will hear from the second place team from Narsi Monji Institute of Management Studies in Bangalore, India. And Aditi Kulkarni will present on behalf of her and her teammate. I know you're both here on the call, and so great. All right, well, Aditi, if you want to take yourself off mute and start whenever you're ready to share.
Thank you. Okay, I'll just share my screen.
Sure.
May I know if it's visible?
Yes.
Okay. Well, hello everyone. So my name is Aditi, and today I will be giving like an overview of how my teammate Vadiraj and I approached the challenge. So we will be giving like an in-depth approach as to how like we went about dealing with the data set. So a little background about ourselves. So my teammate and I are in our final semester, and we are pursuing a bachelor's in applied statistics and analytics. And throughout our coursework, we have had exposure to a lot of theoretical concepts in subjects like data science, linear algebra, regression, time series, and machine learning. And this like theoretical foundation gave us like a lot of like it basically helped us understand how the data was and apply like these concepts to the data set, and that was like a really interesting experience. So coming to how we approached the challenge, so the model that we used was a CatBoost model. And we used a Jupyter notebook where we made use of libraries such as Pandas, NumPy, sklearn, CatBoost, among many others. And the time it took to run our model was around 5 minutes. So coming to the feature selection and engineering. So these are the features that we used in our model. So the metastatic first treatment, breast cancer diagnosis code, breast cancer diagnosis year, breast cancer diagnosis description, and metastatic cancer diagnosis code. So how we identified the important features was using the CatBoost feature importance. So basically, we picked the first 4 variables from this plot. So the plot combined, so these 4 variables combined with the description column is what gave us like the best results. So However, the description column, since it was textual in nature, we couldn't just directly use it with the other features. Hence, we used some feature transformation techniques on it. So the first thing we did was use a count vectorizer for the description column. And basically, the count vectorizer transformed the textual features into like we derived value from there, and it transformed the textual features into like a numerical vector. And because this happened, it split that one column into many different variables in the data set. So then we use like a principal component analysis, which is basically a feature engineering technique. So basically, what it did was because there were a lot of dimensions, so it helped us reduce the dimensions while still retaining all the information required. So we used a PCA after using a count vectorizer. So that I think really helped the model, and it gave us like the best results. So now coming to the training methods. So our first choice was not exactly CatBoost because we weren't aware of the top of that concept at the time. So we initially started off using very basic statistical methods, like one of them being multiple linear regression model. However, we realized that the target variable, like when it deviates from the normal distribution, it's not exactly so. Like when it deviates from the normal distribution, like tree-based methods are more preferred. So then we started using like decision trees and random forest models. However, we realized that we needed more robust models because of the magnitude of the data. So then we started exploring boosting algorithms. So initially, we first used ADA boost and XGBoost. And along with those two, we used the label encoding and one-hot encoding for the categorical variables. And this seemed to improve the RMSE. But finally, we used a CatBoost model because CatBoost proved to be very helpful to deal with categorical variables, and it had like built-in categorical feature encoding capabilities. Excuse me. And this significantly improved our model's performance, and it reduced the RMSE by a big margin. So our model training initially we commenced with the fundamental train test split. And we realized that like the selection of the number of components was very important to improve the model's effectiveness. Um, and that was so important that we didn't even do the hyperparameter tuning. Like the selection of the PCA components were super important. So the important and interesting findings that we thought was the breast cancer diagnosis description had a very important impact on the RMSE. And so incorporating the insights from that column was very useful. And additionally, applying the PCA technique, this like increased the effectiveness of the model, and it contributed to the model's performance. And these insights like highlight the importance of like feature selection and engineering in optimizing model effectiveness. So amongst all the models, like CatBoost Regressor gave us the best results, and the subset that must contain like for it to give like 90 to 95% of the model's performance, the following features must be used. Metastatic first treatment, breast cancer diagnosis code, breast cancer diagnosis year, and metastatic diagnosis code. So that was that. Thank you so much, and I'm open to questions.
Yeah, thank you so much. That was a really good, really interesting presentation, and thank you for walking us through the feature engineering and your process. I really enjoyed your presentation, so thank you so much for all the hard work and really working through the problem and thinking about different approaches. And it's really great to hear about your theoretical background. So I'm curious, did this process raise any theoretical questions that you're interested in further exploring since you spent some time studying the theoretical aspects of this? problem?
I think, I think the description column can actually like be used in a way more effective way. Like there has to be like better ways to like actually derive value from that one column. I think
Because it's
count request
unstructured
is a
text?
good,
Because it was unstructured
sorry.
text?
Yeah.
Yeah. So
And
you're saying that actually working with the unstructured text and deriving more value from it?
yeah.
Yeah.
Like
Yeah.
because I feel like it has way more potential than So yeah, I mean, if given more time, I think my teammate and I would have like done further research, and we would have liked to explore more on that column.
Is that something
And
that you would be interested in exploring more as a research topic?
yes, definitely. I mean, my teammate and I were discussing about like doing further research on the data set.
Yeah.
So yeah, we
So
are definitely
interesting.
interested.
Did you also look at, since you looked at PCA, did you also look at other multivariate approaches?
We did try a latent search,
Mm-hmm.
but it didn't really give us very good results, so we fell back to PCA.
Okay. That's good. That's really interesting.
Yeah,
I would love to hear more as you guys do more research. Definitely keep us
yeah,
updated about your research. That we
yeah,
definitely view
definitely.
this as a springboard. Just it's just the first step. But if there are
Yeah,
interesting research questions that come out of it, we'd definitely like to hear more about it. And I mean, this is, as you know, this is a very active field. There's a
yeah,
lot happening. This is just the beginning. People talk about neural nets as all of this environment. There's a lot of dynamics being incorporated, physics informed and topology informed. There's a lot happening. So
yeah,
we'd like to hear more as you get into research, the approaches that you might be interested in taking. So yeah, thank you very much. Congratulations on a
thank
fantastic
you.
performance, and thank you for a great presentation.
Thank you so much.
Yeah, thank you, Aditi. That was wonderful.
Thank you.
And I believe Preeti was your instructor. I know Preeti's on the call too.
Preeti, great job.
Hi, thank you. It was largely Aditi's and Vadiraj's efforts.
Yeah.
Maybe, a little bit of guidance from me, that's it. But I was just telling them just now that multivariate methods is something we must explore, and maybe look at converting this into some kind of a research paper or do some more research on it. So it's
Yeah.
definitely giving us some leads, and we hope we can get your support on that as well.
Yeah, for sure. Yeah.
Yeah, once maybe we'll come up with some research questions and then run that by you.
That would be definitely
honestly, I haven't had much time to think about it in the last couple of weeks as the new semester started at campus. But yeah, definitely it's something we'd want to take further.
Yeah. How was your experience as an instructor? How did it, as incorporating this into your curriculum, how did that work? Yeah.
Yeah, so this time around, I didn't really have it as part of my curriculum. It was it was more like an out of curriculum, like a club activity. That's how we had managed it this time. So it's kind of difficult to incorporate it into our curriculum. It's not very flexible. So keeping it outside as a club activity is probably the easiest way to handle it, I must say. But I think given Aditi's and Vadiraj's success and they've been an inspiration to a lot of students in the campus. So I'm hoping to make this a regular feature, like I've got some students already coming and asking me, hasn't this year's competition already started? Can we get started on it? So I think keeping it outside the curriculum is just convenient for me right now. But yeah, I'd love to hear from others how if anyone has ideas as to how to incorporate it within a curriculum. I would love to hear from others. For me, I must admit, I just took the easy way out to keep it outside the curriculum.
Can I ask you, at what level are your students coming in? People who who are they at the undergraduate, graduate level? Have they done she mentioned theoretical work, but have they done like linear algebra? Have they done some of the pure math things or
So
algebra?
we have two sets of students here at the university that I teach. One is undergraduate level, which is Vadiraj and Aditi are part of a BSc data science program. Actually, it's called Applied Statistics and Analytics, and the foundation is math, statistics, and computer science. The other set of students they are primarily MBA students with an analytics elective. So the BSc students have more of a theoretical background compared to the MBA students. But there are MBA students who come from an engineering background, so they're also quite interested in, they have a sound mathematical background. So like I was saying, multivariate techniques are definitely something that both set of students study as part of their curriculum. So I must explore how I can make it part of the curriculum. I haven't done that yet, but keeping it outside has worked so far. But yes, I must, I would like to hear from others how they're incorporating it into the curriculum.
This is a great conversation. I'm sure we'll have more to talk about. This is just the beginning of a lot of research. We're just excited that your students have used our competition as an opening to learn more about this field, to learn about all of the opportunities.
I must, the other thing that I wanted to add was the healthcare data set. That's really very challenging, and it's also, I think, a way for me to showcase to students how we can solve real world problems using data analysis. So, getting a chance to work on a healthcare data set was personally for me one of the big highlights. And anything to do with further research in this field, we would like to contribute and help in that as well. So
for sure. And this includes a data set in America. I mean, I'm sure that there are data sets in India. That would be really
absolutely.
It's just something to consider.
Right.
I think that with the coming together of both mathematicians, statisticians, and computer scientists, there's so much that can be done. And each one has a specialty, and it was wonderful for me to hear mathematicians. That's my area is mathematics, pure maths. I'm really interested in the intersection of this. A lot of times we hear computer scientists are coming, which is wonderful. The scaling of these models, but the development.
I recently told my students, when everyone wants to learn Python programming, everyone wants to be a data scientist, but nobody wants to learn linear algebra. And so, it's, I'm also from a mathematics and statistics background. So we do try to emphasize, but, we have scikit-learn to compete with. So
well, I think this space is great in that it has enough room for everybody. If you want to be a computer scientist, you can make a contribution. If you want to be a statistician, there's the room to make an impact. And if you're on mathematics, everybody has a chance to have an impact.
Absolutely.
And it's great to hear different perspectives, and we encourage people with different perspectives to have an impact. So
thank you so much. Thank you so much.
Yeah, we're really thrilled that you guys had an impact. You had a great competition, and we look forward to future contributions.
Yeah, thank you.
Thank you.
Wonderful. Okay, should we move on to the third place team?
Yep.
All right, so third place, we have a team from Bucharest University of Economic Studies in Romania, and Ioana Bielan will present on behalf of her and her team. So I'll let you start presenting when you're ready.
Hi, thank you, Valerie. So my name is Ioana, and I'll be presenting our team solution. We are a group of 4 students from the Bucharest University of Economic Studies. We have been colleagues for the entirety of our undergraduate and graduate degrees. So for 5 years now, and this year we finalized our master's degree in applied statistics and data science. We have a shared passion for research. For example, Anna and Janina have focused a lot on green energy and Bianca on smart development. I have focused on digitalization and sustainable development. So even though we haven't tackled the healthcare data set before, we found the topic very interesting, and it offered us a gateway into the type of research that goes into studying equity in healthcare. All four of us are currently working in data analyst and quant roles, where we have had to use data visualization and machine learning techniques. I would also like to add that last year we competed in the General Women in Data Science Datathon, where we won the first and second national prize together. And we credit our success in this contest to all the new data science techniques that we learned in the previous datathon. So we really enjoy that each year we sort of build on our knowledge. And we think that this is the greatest asset to these datathons. Next slide. Here we have the summary of our solution. So we tried a variety of models, but our best solution was given by the gradient boosting regressor with grid search, hyperparameter tuning, and tenfold cross-validation. Without the hyperparameter tuning, our model would take about 30 minutes or so because we had a lot of pre-processing that took a lot of time. And we wrote our code in Python, and we used a variety of different libraries to identify our best model. We also used AutoML techniques to rule out certain algorithms. Moving on to the feature selection and feature transformations. One of our biggest challenges was pre-processing the data. We focused the majority of our time on this part, and we analyzed each variable with missing data to decide on the appropriate imputation method that would reduce bias and also preserve important information. As the previous presenters have said, this is a healthcare data set, so it is really important to look at the outliers and not just remove them because they could provide very important information. It's a different problem than what we've encountered before. And while initially our strategy was maybe to consider all the missing values as a different category, or perhaps fill the missing values with the median for numerical features and mode for categorical features, in the end, we went with a very individual approach for each feature. So that included, in addition to the imputation methods that I mentioned, a two-way imputation of the missing values by grouping data based on both location, so for example, the state or the region, and also the quantitative feature. And our model performance was increased after we dropped the features with a very high variance inflation factor due to the multicollinearity present in our dataset. Additionally, we also grouped the patient ages into bins, and we used one-hot encoding and label encoding for categorical data. Again, I want to emphasize that we used individual approach because we have both nominal and ordinal features, and we couldn't just create the pipeline that would deal with all of them from the beginning. Here we have the feature importance graph. So like I mentioned, we were interested in the feature important metrics along with the featured variance inflation factor to decide on the features to keep. But here we have the feature importance plot for our best model, the gradient boosting regressor. And our model identified the metastatic first treatment, the breast cancer diagnosis description, and the diagnosis code as the top contributing factors to the predictive model. And to further emphasize our approach, our individual approach to pre-processing the features, I would like to focus on the breast cancer diagnosis description that we saw previously, how important it was. And I see that it appeared in all the models mentioned before. And this feature required special NLP transformation techniques such as tokenization and removing stop words. And something that we found really interesting, and perhaps it could be a research question, is how rich and detailed the diagnostic information was. Specifically, it even mentioned the exact location of the cancer within the breast, such as on the left or the right side. And we believe that this granularity helped our model, and it is also very crucial for personalized treatment plans. This is why we analyzed the frequency, and we believe it was such an important variable to our model. Moving on to the training methods, we looked at a variety of regression and tree-based algorithms. But we focused very heavily on hyperparameter tuning. And while this was time consuming, we think it was a really big part of our success, since we managed to get a good result with just one algorithm. And since we have a background in statistics, theoretical statistics, we used a mix of classical statistical techniques to provide a stronger understanding of the data. And like I said, preserve important information. However, we also wanted to integrate modern machine learning methods that allowed us to enhance the efficiency and fasten the process. So like I said, we used AutoML tools that automated the selection of the most appropriate algorithms and hyperparameters. This allowed us to quickly check what algorithms we should test more, or the ones that aren't really worth testing and tuning for. And where possible, we introduced pipelines to streamline the data transformation process. And while I mentioned all these models, we also tested ensemble models. So we used a combination of gradient boosting, cat boost, like gradient boosting machine, and random forest regressor in a stacked ensemble model with rich regression meta-learner. But as we see, it was a simple model that did give our best solution in the end. And here we have our interesting and important findings of the part of our presentation that we wanted to focus on, and that is the equity in healthcare theme of the Datathon. So from our exploratory data analysis, we wanted to see if there are differences in the periods between diagnosis and first treatment and the demographic variables. And the difference between the first treatment date and the breast cancer diagnosis date was greatest on average for the patients with commercial insurance type. And among the races, Asians and Hispanics had, on average, a longer waiting time to first treatment. And for us, this was very interesting, and perhaps a discussion can be formed why these differences exist. We are aware that this data set is in America. And for example, since we are in Europe, perhaps we had to document ourselves more on the different type of insurance types that exist in America, which was something we did enjoy because it was something new. And here, like I said, we put emphasis on hybrid methodology. So that meant we also tried spatial modeling, and we did that by conducting individual regression analysis for each state separately, so that each model was tailored more to the specific characteristics of the state. And here we have a visualization of the treatment periods between diagnosis and first treatment. And what we found very interesting was that the longest periods were in Alabama, Alaska, and Iowa. And we find these periods much longer than those in states like Missouri, North Dakota, or Idaho. And even though it wasn't among our best performing models, we do think that for future data sets, it could be helpful. Even models like spatial lag or spatial error models could be very interesting. And finally, on the interesting things that we tried, we noticed from previous competitions the importance of testing the distributions of the variables and comparing the train and test set, because we saw that there could be very important differences in these distributions, and it could be an indication of a serious problem in the data set. So, however, for this competition, that wasn't the case. With the exception of a few variables, we did not notice a general problem. But we wanted to mention that because we know how important of a problem it could have been. And here we have a visualization of our top models and how the public and private scores differed. So we know that our biggest challenge would be finding a stable solution that wouldn't be prone to overfitting. That's actually one of the biggest challenges in these datathons, because you could have you could be number one on the leaderboard during the contest and then drop 100 places. So for us, this is why we focus so much on hyperparameter tuning and cross-validation, because we were looking for the most stable solution. And so in conclusion, our analysis revealed that metastatic first treatment, diagnosis description, diagnosis year, and diagnosis code were pivotal. They accounted for 90% of the model's performance, and despite extensive experimentation with various ensemble models, in the end, the most effective results were achieved with the straightforward gradient boosting model. So this simplicity combined with robustness for us underscores the power of a well-selected feature and solid algorithm. And we think it was worth all the time we put into the pre-processing, because in the end, we achieved a good result with the gradient boosting model and not the ensemble models. Thank you for your attention, and I'm happy to take any questions.
Yeah, thank you.
The rest of your teammates are also on the call, so if any of you want to add anything, feel free to as well. Great job too.
Yeah, thank you, Anna. That was fantastic. Really enjoyed your presentation, and I enjoyed how you've sort of put together your story, bringing together different aspects of statistics and math into the story, and it really aligns with how I think. I mean, a lot of the tools are the tools, but they're really meant to flesh out the story, the underlying data, underlying statistical story, and you really fleshed it out very well. And it was great to hear about multicollinearity and variance inflation factor. It's something I spent time on. It's really great to hear that you actually did research on that. And it was also really good to hear about the spatial modeling. I think that was very insightful to see the differences between states, and you picked up on that. And also, it was also, when I prepared the data set, the things that I put in to make sure, wonder if people will pick up on it. And it was also very interesting that you picked up on the breast cancer, the description code and the actual quadrant of the breast, and you guys actually picked up on that. So that was great that you used all these different techniques, the NLP, the spatial modeling, and different approaches. Were there other statistical approaches that you were maybe thinking of, looking at distributions and looking at differences? I see that you might have done some t-testing, f-tests or things like that. Were there other statistical methodologies that you were that you might have done or would have done in the future?
So yes, it was an interesting contest because we also looked at the other two datathons that occurred this year, and we saw that even though the datasets were similar, the solution for them was different to what our solution was in the end, right? Because for the previous two datathons, the solution was an ensemble model. So some teams had 17 models inside an ensemble model, and that was their best result. But for us, it was very interesting that it was the simple model that gave the best result. And for us, it would be very interesting to see why, to perhaps analyze the previous datathon, the last one, which was also a regression problem, and see if perhaps the winning solution there would have worked for our data set, and see exactly why it was that the simple model worked best in this case. I think that would be interesting. I don't know if my teammates want to add something else, but that was one of my questions. Why it worked in this case.
Yeah, I think it's interesting to see that the distribution, the relative distribution training and test set in both competitions, and see why certain models fit better for that the other competition versus this competition. So I think it would be really interesting to explore that. And also, I think you also looked at outliers, and that distribution of outliers is also very informative.
Yes, and it's very interesting because this is why we were a bit pressed for time. But what our approach was, we would try a pre-processing method, and then we would test a predictive model, and it would have been interesting. We tried it, but it would have been interesting to try even more outlier removals or imputation methods and see what the effect would be. And we documented part of part of it, and this is how we got to this solution. We had a lot of alternative solutions, but yeah, there's so many outlier treatment methods and so many imputation methods, and it would be really interesting from a research perspective to see exactly which is the best method for preserving the data for bias. For example, maybe we could have tried demographic parity, for example, and try to maintain that distribution correctly in the test and train, because it's very important. That would reduce bias and when dealing with healthcare data.
Yeah, for sure. Maybe this is a springboard for you to do more research. I mean, we can, this is, just the first part, right? Just the beginning. So we invite you to think about, research questions that might have come from this competition and, pursue those research questions. So we'd love to see it if you go ahead and pursue that research. We'd love to support you on that. And we're really excited to see things like that. So, definitely reach out to us if you pursue that. We're always interested in seeing people take our competitions and run with it, take the next step. So there's a lot, like I said, this field is just growing by leaps and bounds, and all the progress that we make, it is kind of the basis for further questions that are raised. And there's more research questions that come out all the time. So we'd really love to see that, you run with it, and then your findings are a contribution to the community. We can see that. Yeah.
Thank you so much. Janina and I, for example, we are going to continue with our PhD studies, and we would be interested perhaps to work on an article on this and further our studies. And I'm sure that even Bianca and Anna, who have also published articles, would be interested about that. So thank you so much for this contest, for this opportunity, and offering this platform to us. It's great. Thank you so much.
Yeah, thank you for contribution. Thank you for all your hard work. And we look forward to seeing you again in the future. Thank you.
Thank you.
Great, thank you. Thank you for your presentations. All of you did a great job on this year's university competition. Like I said, this is the first time we've done a competition like this, being exclusive to the university students and at a slightly more advanced level. And so we're really appreciative of all the efforts that you all put into it, and the instructors who supported. So does anyone else have any final questions or comments that they'd like to raise before we close out? No? Anka, I'll give a shout out to you as well. I know you also were an instructor this year for our first place team. I meant to call you out earlier, and I'm sorry about that, but I just wanted to give a quick shout out to you, Anka, for your work in supporting Aditi as well, and Vadirij. So great job.
Thank you again for the opportunity to work on this data. I think it's very useful for students to get in touch with this kind of data. It's difficult to work with a lot of students on this kind of data, but yes, you all the time find very passionate students that really allocate time to work on this. And I want to congratulate again Andrea and Petrus for this result. And I want to thank you again for the Datathon. And hope to see you in the next year.
Yep, sounds good. Yep, we will plan on revealing next year's theme shortly. So there's a meeting that the instructors are invited to attend next week, where we'll kick off the theme for next season. And of course, we hope all of you students join us again next year and continue to evolve your work in data science and in your research and just in your overall studies in your schools and universities. So, all right, well, we'll close out for today. Thank you all for your hard work, and thank you for attending.
Thank you all very much.